Hello guys, welcome again to your computer drawing class. Today's class is going to be about auxiliary views. We're going to learn what an auxiliary view is and what is it for. We're going to learn also about the alignments of the views. We're going to keep always the alignment because you always are not doing that, so I wanted to include this on today's topic. We're going to talk a little bit about the creation of reference geometry. Reference geometry sometimes is very useful, sometimes is necessary to create one of the geometries you will need to create for your projects. So first of all, I'm going to start the lecture with a presentation, which is right here, and follow the presentation with an exposition on the software and the SolidWorks, how to create the reference geometry. And you gotta follow these two videos to create your deliverables for today, which are these. You're gonna see my calendar in Blackboard to check out for the dates for the deliverables. And from the first video, you gotta create the solid, because you have not the solid to start working with the reference geometry. You gotta create first the solid and then the reference geometry. I'm gonna show you here how to create reference geometry. And for the second video, same thing. You gotta create the solids because you don't know. They are free size. It doesn't have to be exact size. It just has to be similar. The important for today's class is working on the reference geometry. So don't pay much attention to the solid. Just get practice creating solids, but pay much attention on reference geometry. So let's get started with the presentation on auxiliary views. Auxiliary views are used when you have some geometry with non-normal, with non-orthogonal size. For example, this plane here, which is inclined, if we project the top view, we will be looking at this. If we project the right view, we'll be looking at this. If we wanna dimension what is the length, if we take this length here, it's not giving me the full length of the element. The element I'm looking for, the length I'm looking for is this one. But this length is not shown neither on the right view, neither on the top view. So in order to have a good look, an exact look, if I'm interested in this square, this rectangle here, and I want to see the dimension of these rectangles, I necessarily have to use an auxiliary view. So let's check it out. An auxiliary view requires an element to create it. So the auxiliary view is not going to be normal to the rest of the views. It's going to be normal to this element right here. From this element, I'm going to deploy the auxiliary view. And now the rectangle with the dimensions I'm interested in, which are this one here and this one here, now it's visible. Now I can take the exact dimension on the element of interest. If we are not interested in other geometry but the rectangle right here, we can only show this part. It's not necessary to use these parts. If they are not from interest, when I use a different color, we can just eliminate. And we gotta see something like this, because we really don't care about this part here. This is not from interest because they are in a different plane. They are not showing the right dimensions. We are interested in this part. So we can show something like this. So that's the use of auxiliary views. The auxiliary view can be coming from either the front view, can be adjacent to the top view, or can be adjacent to the side view. It doesn't matter, it's always called an auxiliary view. We have an additional example here with the box. The box to show the front view, the right view, the top view, and how we'll be looking at the auxiliary view. This would be an auxiliary plane, and this would be my auxiliary view. Sometimes you would require it when your geometry has these inclined planes. This is an example of a geometry. You see, there is not orthogonal anymore. It has some elements with kind of a slope over here. So this slope will make the circles right here to be shown as an ellipsis. If we take, for example, this view right here, which would be my front view, the circles of interest, if I want to show the diameter right here, this is not correct, because this is not the diameter in this view. In this view, this is an ellipsis. This is an ellipsis. Okay, let's use the bottom view. If I project this here, this is again not a circle. I gotta use an auxiliary view. If I project from this element, from this auxiliary plane, I project a view, I deploy it. Now the circles are shown as circles. And now I can create a dimension here. This wasn't right, because it's not a diameter in this view. But now this is right. Now it's a diameter, and it can be shown as a diameter. An additional example would be this one here. This kind of geometry, and we are interested in this length. Well, we gotta show again an auxiliary view. So this will be my lateral view from this side. This will be the view, and from this view I will deploy an auxiliary view, which is this one. So in any case, when you have this kind of inclined planes and you are interested on the geometry above it, you gotta use an auxiliary view. Okay, that's the part for the auxiliary views. And then I'm going to show you how to create reference geometry. Imagine we gotta create an additional sweep on this geometry, but we cannot use these planes anymore because these planes are not on the location of interest. So we gotta create an additional planes. First of all, I will create a new document from scratch and show you the reference geometry command. Reference geometry command is found here under the Features tab, and you can create either planes, axes, coordinate systems, or points. Usually we create planes and axes. Okay? So let's start with plane creation. To define a plane in the space, you require 3 points. Let's talk about the blackboard. The blackboard, if it will be floating in the space and we want to fix it, fix one of the points, the rest of the blackboard will be moving and this point is fixed. If we fix 2 points for one plane, it still can do this movement. If we fix 3 points for the blackboard, now it's locked. It's completely constrained, it's completely fixed. So we require 3 points. Or we require a combination that constrains all the degrees of freedoms. For example, if we have one plane and we talk about parallelism to this plane and a distance, it fully constrains the second plane because it cannot move. If I fix the distance and I fix the orientation to be parallel to this plane, it cannot move anymore, nowhere. So let's start with that example. I will select one plane and a distance to create a reference geometry, which is an additional plane. Let's check it out. You gotta, this is tricky. Here, under this plus sign, you gotta click on it, and you will see your tree, your full tree. Sometimes it's very tricky to find this, so check it out. So I'm gonna select the front plane, and I wanna create a plane which is at a distance of this front plane. You can select here the distance. Let's select 2. You can type in number. Let's select 4. If you have different copies, you can here add additional planes. Okay? You have these options. Let's say I don't want it to be at a distance. I only want it to be parallel. Then we need an additional second reference, like a point, an edge, to specify where, because parallelism defines the orientation but not the location. So we still need to define another reference to make it coincidence. We'll check it out with the solids. Right now it's confused without having anything else. So, but I can talk about perpendicularity. I can make it this plane in yellow is perpendicular to my reference plane, which is the front plane. Okay? So let's create this one here as a distance, and I will create only one. And this is my new plane. Okay? Let's create some geometry from the front plane. I will create a square. And this is an extrude command. Very basic, very simple, you already know this one. And now I can show you the other options. Reference geometry. I click on reference geometry and it's asking me for either first, second and or third reference. I will use the first reference to be this plane here, and I will call it to be parallel to this plane. So I click on parallel. And the second reference, which is now in blue here, is waiting for my input. I will select this edge. So the software will understand the new plane, the new reference geometry has to be parallel to the first face and coincident with this edge. So the new plane, it will be placed here, coincident with this green edge and parallel to this pink surface. I click on OK, and I have a plane number 2 here. Now create an additional plane which is coincident with this face. So I can select on reference geometry again, plane, select this face. If I select coincident, it will be right there. It's fully defined here in green. It's telling me that I don't need any additional reference. It's fully defined now. We have plane number 3 now in here. Let's create a new axis which is coming from 2 planes. From plane number 2, which is this one, and the intersection on plane number 3, this one, and you see in yellow there is an axis. When we intersect 2 planes, 1 plane and 2 planes, the intersection is aligned. In this case, in this software, it's called an axis. So the axis will be created in the intersection of whatever 2 planes. Now, if I click on OK, a new axis, a new reference geometry, it will be created here. So reference geometry allows me to create new geometry wherever it was nothing there before. I will explain. So I will create on the arrow to create this new axis, and let's imagine we want to create a new extrude from this plane number 1. If I had not the reference geometry, it would be impossible to create this new and extrude this new extrude here. So I will create a polygon right here. This polygon is starting from the plane number 1, which is a reference geometry. So reference geometry allows me to do this kind of things. Now let's create a new plane at an angle, so you can see one more application of the reference planes. So I will select plane number 3 and an axis and an angle here. So I can create planes not only parallel, not only perpendicular or coincident. I can also create planes at an angle. I will select 135 degrees. It's fully defined because I'm selecting 1 plane as a reference, 1 axis as a reference. I click on OK, and I will create a new sweep, new extrude, excuse me. I will use also a polygon. I will use 8 sides, and I will do it right. Without the reference geometry, it would be not possible to create these things. You see? So this is one of the uses for reference geometry. Now, we can come back to here and please work on video number 1, on video number 2, and create the geometries and practice creating reference geometry. Thank you very much. Have a nice day.